All right, so yeah, nucleus is in the middle. What's in the nucleus? You just said it. Protons. What charge are protons and neutrons? Neutral, respectively. And what's the other thing in there? And where are they at? Outside. Very good. All right, now, number 2. What was the point of kinematics?
Understand the motion of objects.
What's that?
Understand the motion of objects.
Excellent. Very good. Probably another way to say it, the way I would typically say it, but that was excellent, is just we're describing motion. We're describing the way things go from here to there and how they do it in that particular process. All right. What is necessary for you to answer kinematic equations?
3 of the 4 variables.
3 variables, right? Specifically, actually it's 3 of 5, right? 3 of 4 in the equations themselves. But if I put these up on the board, the 5 that we typically deal with, what I want to show you is this. This right here, velocity initial, can be described as one of the initial conditions, or the original way an object is moving. Acceleration is right in that exact same boat. Both of the two of them are essentially the way it is at the very beginning. So if I have the initial conditions of an object, the only other thing that I really need in order to solve for anything else is, what the heck do you want to know, right? For example, if I have these 2 here, the other 3 that are up here are just like, what do you want to know? So if I said, like, I give you time, like 1 second, what you could then find is, how far did it change its position during that 1 second? And after that 1 second, how fast is it going, right? Or if I said something like, we're going to throw it to its total height, that would tell us the velocity final is 0, right? And then what could you find out? What's that? One more time. What is this? Change in position, or the displacement for the object during that amount of time, and we could also figure out exactly how much time it took. What I'm trying to highlight here is these 2 right here are the initial conditions. How fast you're going in the very beginning, and then how that is going to change. Acceleration is one of the most important, actually it's the most important in motion, because I told you this example before. If I'm standing here and I don't accelerate forever, where are you always going to find me?
Right there.
Right here, right? So it kind of holds true then that I need to accelerate in order to see basically motion happen, right? And even if I'm moving at a constant speed, assuming there was no door or anything else in my way, if I never accelerated ever again, you'd always find me that way, right? So in order for there to be motion, we need to have some type of acceleration in the initial conditions. And then all the things left are just, what are you trying to figure out? All right, number 4. Stay. All right. What? No, it won't. Anyway, what is mass? You actually answered the second one. So remember, if you always have trouble with that, the reason why a lot of people have trouble like that is because the original definition you're given for mass is anything that takes up space. But the space that it takes up is not mass itself, it's actually volume. If you ever have trouble with math, I always try to think of the kitchen. Every time you cook in the kitchen, you are always dealing in volumes. You hold a cup in your hand, an actual cup of measurement. Anything you put in there can be a cup, right? If I put in sugar, if I put in sour cream, if I put in feathers, I don't know why you're cooking with feathers, it's all a cup because it all takes up that exact amount of space, right? Do they all have the same mass?
No.
No, definitely not. What is mass?
How much of something?
Yeah.
You're right. Because really it's some things. Probably the easiest way to say it is the number of atoms, not weight. Because it's actually just a number of things. It's actually strange to think about, but it's kind of like, in other words, similar to dozen. Dozen, of course, is 12 of something. Atoms are the specific number of atoms in your body. Now, the reason we don't usually count in atoms and we use kilograms instead is because if I try to count all the atoms and show, it would take a lifetime of lifetimes. I mean, honestly, if I could see each atom and I could not lose track when I was on 1,740,000,000 million and so on and so forth, even if I didn't lose track, it would still take me an entire lifetime to do because there's that many atoms. I think I've used this example before, but what are there more of? Grains of sand in all the beaches in all the world, or atoms in a single grain of sand? Because there's a bunch of them. Okay? So, it would take forever. So this number of atoms, this amount of space. Does my number of atoms change? my number of atoms change in my life? Definitely. How? As a matter of fact, your number of atoms probably changed about a half an hour ago.
Food.
Yeah. All of you just became more massive. So, that's not an insult. I'm just saying it honestly. You have more mass. Right? No. All right. I'm not going to go there. You have more mass. You have the exact amount more mass. If you could count all the atoms in that cheeseburger or whatever you ate, and then you counted your number of atoms, and then if you measured at the end, it would be both of them together. Right? Okay. So, you could also lose atoms. Right? You lose atoms if you cut off your arm. Well, technically you don't lose your atoms, you just aren't in control of them anymore. They're still there, they're just over there. I mean, if I explode, I'm still the same number of atoms, I'm just not around to see them anymore. There's some Spain hour up there. Down there, you have a little bit of Spain hour on you. Oh, all right.